So originally, I had an idea to start my talk with a very powerful quote by this famous scientist. And I was so excited about this that I shared my intent on Twitter. And immediately, one of my friends warned me, you see, the thing with those internet quotes is that you can never really trust the authenticity, can you? So I decided to do something more important instead. I decided to pay forward this warning and to give you a heads up on the potential dangers of this talk. During the lab trials of this talk, some of the audience experienced following side effects: increase of appetite, drooling, and in severe cases, the hunger. So if you have any of these symptoms or history of any of these symptoms, there's still time for you to change the room. Otherwise, I advise you to acquire doctor's approval or wife's, husband's, kids, or whichever entity you answer to, just to be on a safe side. As for myself, I take no responsibility for what's going to happen, and I pass all the responsibility to the organizers of this event. Now, let me just continue in this official tone by introducing myself. I'm Miroslav Jonas, or shorter Miro. As our moderator said, I was originally coming from Serbia. I'm now living in Austria, where I work at 5G Systems. There we're building gaming solutions of the future. I'm also one of the organizers of Angular Vienna meetup and one of the founders of Angular Austria Association. Now, if you would like to know what I had for breakfast today, or how fine the sand is on a beach that I go to on my vacation, unfortunately, you won't find this out by following me on Twitter or any other social channels using this handle Miroslav, but you might find some geeky, boring tweets and posts, and maybe less boring reposts and retweets. Now, let me share a story of how I got acquainted with RxJS. I was switching my company and starting this new project, this typical big enterprise internal application. As some of us already had experience with .NET and Angular JS, and we wanted to be future-proof, we decided to take Angular 2 and .NET Core, both of which were at the time in alpha stage. So our CTO was quite understanding, and he gave us full freedom to choose our tools. And in a way, it was adventurous to start a really big project with using undocumented tools that were in alpha stage. You could say we were brave, or maybe you could say that we were foolish. Now, Angular came with a couple of dependencies. First dependency was TypeScript, and this is something we were used to because we were doing anyway some TypeScript languages before, so it was a benefit for us. The second thing was Zone.js, and Zone.js, it's kind of just sitting there behind, and you don't really see it unless something breaks in the application. And finally, our star of the day, RxJS. Now, I did my share of pub/subs and event-driven architectures, so reading this reactive programming paradigm didn't seem like too much of a big deal to me. And the first time I saw RxJS was when I was making my first HTTP call to backend. And this is when you notice the first difference. Instead of .then, you are now writing .subscribe. And I was thinking to myself, why the hell couldn't they just use the same terminology? What's the big deal? And the answer was, oh, because this is observable, not promise. So I went to the website to check what observable is, only to find definition like, observables are API for asynchronous programming with observable streams. So observables are explained with observable streams. You see that kind of recursion there in the definition. So naturally, this didn't give me the answer I wanted, so I asked our local Angular 2 expert, and after a couple of unsuccessful attempts of dodging the question and confusing me even more, he finally said, look, RxJS is just too complex to explain with words. In order to understand it, you need to switch your mindset to reactive, and it takes at least 2 weeks to do so. Well, luckily, this wasn't really true. So today, I'm gonna try to wrap this 2 weeks into a couple of minutes. I'm gonna try to explain what reactive is, using nothing but words and maybe some images. And finally, once we have this basic set, we will together build one game. Now, this is the definition that actually helped me when I was learning what RxJS is. RxJS is a combination of best practices from observer pattern, iterator pattern, and functional programming. In order to understand this sentence properly, let's dissect it into parts and explain each part separately. And I'm going to do this in a slightly unorthodox way. I'm going to use metaphors from cooking or rather eating. So let's start with the first thing, functional programming. Now, functional programming is a style of programming where you explain the code or the logic with a chain of functions, where each function can have some input parameters, can have some output, and each function is pure, so no matter how many times you call it, for every set of parameters, it will always give you the same output. Now, this is a bit too technical, so let's try to explain functional programming with Scrambled X. And in order to understand the benefits of functional Scrambled X, let's see what non-functional Scrambled Eggs look like. This is your typical kitchen recipe. First, you assemble some ingredients, then you process them mechanically, then you have some cooking time, and finally, your food is ready. This is a rather simple recipe. And although it's a simple, and most of you probably know it already, it has some flaws. It's missing some vital information. For example, we might assume this is a recipe for one portion. We might also assume it's meant for one cook to be made. Now, what if we have two cooks? How can we parallelize things? Or what if we need two portions, or we have a person that is 1.5 hungry? How can we double some things? Do I need double the amount of eggs? How about 2 measuring spoons or 2 pans? Should the heat be twice as high? Now, these might be trivial or ridiculous questions to you, but imagine for a second that this is not your favorite food recipe. This is some complex chemical reaction you have no idea about. Would you still be comfortable in answering all these questions? Probably not. And surprisingly enough, when we do development, these are the questions we usually have on daily basis. How do we do things in parallel? How do we shuffle the computation? How do we reuse the resources? And finally, how do we handle the exceptions? Now, this is how the functional Scrambled Eggs look like. You can immediately see that it's way shorter. You can also see that there's some causality presented just by the way how the functions are nested. So we can see now that heating butter in a pan and beating eggs and salt and pepper can be done in parallel because those are the functions on the same level. You can also see that the steering function is their, let's say, parent function, and it has to wait until these inner functions are done, or until we can start the cooking. You can also see that the butter doesn't have to be melted on a medium heat. It can be melted on any heat, but then the mixture should be heated on medium heat, and it should be heated until it has thickened. And finally, when this function is over, we can serve it. Now, for the next pattern, I would like you all to close your eyes. I would like you to imagine your favorite pizza, the best pizza in the world. The choice of topping is yours, of course, the crust, everything. Just in case one of you doesn't like pizza, unfortunately, I have a bad news. You will never learn what RxJS is. Now, let's get back to pizza. So you have this perfect pizza. It's standing on a table right in front of you, and you slowly approach this pizza, and the question normally pops up, could I have a slice? And pizza says, of course, here you go. And you take this slice and you start eating, and it's just a perfect slice of pizza. Every bite is so perfect. And soon you're done with this slice, and you think, how about next one? Hey, pizza, can I have next one? And pizza says, yeah, of course, here you go. And the next one, and the next one. And at some point, pizza will say, sorry, I don't have any more slices left for you. And this is how your iterator works. So it gives you opportunity to iterate over a collection of items, one item at a time, and eventually it will give you the information that your collection is complete, that there are no more items left. Now, observer pattern works slightly differently. I was raised in a small town, and we didn't really have a bakery that would deliver fresh bread all day long. Instead, what you had to do was reserve your bread one day ahead, and then the baker would deliver it early in the morning to your local shop, and you would have to go to collect it. Now, you could theoretically collect this bread all day long, but if you would come later in the afternoon, they might assume that you just won't show up and they would sell your bread, or this might be the bread that nobody wanted and everyone touched throughout the day. So the key was to be there in the morning to pick it up. Now the problem was that my sister and I were in school, parents at work, so it was my grandma who went to pick up our bread as well. So every day after school, I would stop by my grandma's, I would collect the bread, but before that, I had a portion of scrambled eggs, the one you saw before. I was raised on scrambled eggs, but my grandma's specialty actually weren't scrambled eggs, but pancakes. She would make these perfect pancakes, and all it took was for me to say, "Hey grandma, I would like some pancakes." And minutes later, the first pancake would be flipping in a pan, and the first pancake would land on my plate. And then the next one, and the next one, and the next one. And at some point I would have to say, "Hey grandma, stop, I'm full, I can't eat anymore." This didn't really happen because one thing I didn't lack was the number of cousins, so there was always someone to take the next shift in eating pancakes. But you can see how the observer works. So you subscribe to some events, and as soon as event or item is ready, you get the first one, and the next one, and the next one. And eventually, when you're done, when you don't care about this anymore, you can unsubscribe. Now let's recap these things that we learned so far. So observables are a combination of observer. You can subscribe to something, and you can unsubscribe. Second, it's a combination of iterator. You can get items one item at a time, and you can also get information once your stream is complete. And finally, you can apply multiple functions. RxJS has a tool belt with 100-something functions that you can apply based on your need or your situation that will let you to manipulate the stream or items in a stream in the way that's fitting to your challenge or your problem. Now, if you're asking yourself what can be observable, well, the answer is simple. Everything can be observable. This floor I'm standing on, observable. Chair you're sitting on, observable. This pointer, observable. Even the sound coming out of my mouth, observable. So if you can imagine something, it can be wrapped as an observable. Now, observables are dealing with streams, but they don't necessarily have to be asynchronous. Depending on the item you're wrapping, it can be synchronous or asynchronous. So if we wrap HTTP call, due to the nature of HTTP call, it will be asynchronous. But if we wrap static objects such as array or string, due to the fact that this object is synchronous, the whole observable will be synchronous. And the best thing is that RxJS doesn't really care. Regardless whether it's synchronous or asynchronous, all of these streams will be treated just the same. Now, there are though some differences. There are two major groups of observables, so-called cold and hot observables. And in order to explain this, I will have to use one of my favorite meals, sushi. When you want to order a sushi, there are typically two types of restaurants. The first one is your typical restaurant. You go there, you find a seat, you have a seat, then you take the menu, you order the meal, and then you wait for the waiter to bring you the meal. So this is how the cold observables work. Your observable or your meal didn't exist, hopefully, before you came to the restaurant, so it was made there for you on the spot. The second type of the sushi restaurants is so-called conveyor belt restaurant, or how Viennese like to call it, the running sushi. Now, for those of you that don't know these restaurants, is a type of all-you-can-eat restaurant where you have a big rotating belt in the middle of the restaurant, and there's a team of chefs that are making fresh sushi all day long and some other sweets, and they are putting it on this belt, and all you have to do is have a seat, subscribe, and then when the first item arrives, you can snatch it or fetch it from this belt. And you can eat as long as you want or as long as you can. And once you're done, you can just pay and leave. And the thing is that these chefs were creating the food before you came to the restaurant, and they will be probably making food after you leave the restaurant. So this is how the Hot Observables work. They produce events regardless whether you're listening or not. In development world, this would be your typical mouse moves or keyboard clicks or any other event that's just being fired constantly. Now, we can also see with the first restaurant the difference between observables and promises. Promises are not cancelable. So when you create a promise, you in a way promise that you will wait for the response. So if observable was your restaurant, you could order food and then you could stop waiter and say, hey, actually I don't want sushi, I want maki, or you could just run away from the restaurant without paying. It's all fine. Observable doesn't care. And with promise restaurants, you would be chained to the chair and you wouldn't be able to leave. And once you order the food, you have to have this food. You can order the next one, but you have to have this food. And they call this the closure. Also, promises are asynchronous by design, and they guarantee that they will be asynchronous, while as we saw, observables depend on what's being wrapped. Now, this should hopefully give you enough information to know what observables are and how they work. But in order to really understand how this is done in practice, we're going to do some serious cooking time. And I did pay my tributes to the demo gods, but just in case something goes wrong, and in order for you to know what we are about to build today, I created this small video of the game. So as you can see, the game is called RxJS Chef. It's a perfect world where food just falls from the sky, as it normally does. And it's your job as this chef to collect each item in a basket. And you have 3 lives to spare by doing so. Also, to make things a bit more interesting, depending on the health ratio of the food, the healthy food will fall slow and will bring the most points, while the sweets and the crap food will bring small amount of points but will fall super fast in order to kill you. So, oops, wrong slide. So let me now go to my computer and switch to my IDE. Now, can everyone see the code, or should I increase it? You people in the back. All good? Awesome. So let me just start my bundler. As you can see, the game is on the right side. At the moment, we have just intro. Someone was asking that whether the canvas can be transparent. This is transparent canvas, so only this chef hat is being rendered. Everything else is transparent and showing the background from the page. Now, as you can see here, this code is rather simple. So we have some canvas element that's being fetched from the document. Then we have this init canvas method. And when you go to init canvas method, we see that we are just calculating the width and height ratio in order to have our rendering as sharp as possible. And then we're returning this context back. And finally, we have draw intro, which doesn't do much. It's just using canvas method to draw the intro. And this intro actually represents my so-called drawable object. Let me just scroll up to the definition of the drawable objects. So I created this simple interface where everything I'm drawing on the canvas has SVG field, which is nothing but encoded base64 SVG DOM. And then I have image where I'm going to store the loaded image from this SVG. And finally, as I mentioned, every food has the health ratio. Now, I did also a couple of more methods up front. So, oops. One of them is I created the GameState. Now, this is the GameState that we have. As you can see, GameState has a position of chef, which is only the x-axis because chef is always on the bottom line. We have also our score, food collected. We have number of lives and flag whether the game is running or not. And underneath, you can see that we have our generate initial state, which sets the game onto true, chef to the middle of the page, to the middle of the game, score and food collected to 0, lives to this constant lives, which is 3. And finally, we are generating the food item, and generating the food item is just selecting randomly one food from array, setting position again randomly along the x-axis, and setting the position to -1 so that it falls from the top. Also, we have GameRender. I have no idea why this is cut off. We have game rendering, so this is the main function which takes our state and uses the canvas or context of the canvas to render the game. If we still have lives, it will generate all these items: chef, food, basket, lives, and score. If we don't have any more lives, we're gonna just draw game over. And all this drawing is just simple canvas stuff that James already showed, so you can look at it later. I will provide the full source code, but now let's go back to our main file. So as you can see at the moment, we have just intro. Now, we need to interact with this game somehow, so we're gonna now listen to keyboard clicks. So let me start with creating a from event observable, and we're gonna say we are listening to the document and we're interested in key down. And now if we subscribe to this and we console log it, if I go here and start pressing some, maybe I need to reload this. Yeah. Now if I click, you see that there's a bunch of stuff coming out, and these are keyboards event. Now, we don't necessarily care about the whole keyboard event. The only thing we care about is this code, which tells us exactly what this key is. So we're going to use our first operator. When you're linking your operator functions to the observable, you are doing them in this pipe structure, or this pipeline, let's put it that way. So first we're going to map each event to the event.code. Ignore this TypeScript complaints. Now you can see that we actually get the code printed out. Now we don't care about all the code, so what we care about is key left and key right to move the chef, and key down to speed up the food falling. So we could instead write something like this. So we can say if event.code equals arrow left. And now we don't want to deal with arrows. I created GameActions. It's a simple enum. This, as you can see, has 3 potential values: move down, chef left, chef right. So every time we press arrow left, we're going to move chef to the left. Just copy this bit. And now every time we press arrow right, we're going to move chef to the right. And finally, if we press arrow down, we're going to move down. Now, in case it's some other key, we can just return null. So let's see what happens. Now you can see that, just a second. I probably made some mistake because this is not printing anything. Okay, maybe this wasn't correct type actually. Let me just console log the event.code. Ah, yeah, true. That's the beauty of live coding. You always forget something. Perfect, thanks for the help. So now, if I press here, you can see that these keys are being returned, and if I press something that shouldn't be used, we get null. But we don't really care about these nulls, right? These are not the events we need to know about, so we can just filter them out. We can say that if action does not have a value, then we're gonna throw it away. And now you might not see, but I'm pressing randomly some keys on my keyboard and nothing is happening. Now, I also created one handy function just to make this shorter. So we're gonna use this key to GameAction, which is doing exactly what I did now with a slightly shorter code. Now, we have our game actions, but nothing is actually being rendered. So we need to map this somehow to our state. For this, we're gonna use the scan operator. The scan operator works similar like array reduce. So you have some seed with which you start, and then you have your accumulator function, which takes the previous value and combines it with the current value to produce the new accumulated value. Now, array reduce only returns the final value after it went through the entire array. With scan, it returns every step of the way the latest value. So we're going to use now function which I created is called calculate state. I'm going to show you in a second. And we're going to start with generating the initial state. And now if I press some buttons, you can see that there's some state being rendered here or logged here. Now, this is fine, but we would like to render this, right? So we're going to now call our render function. So we have render state, we provide state and context. And we have our first screen. Now, if I keep pressing down, you can see that I can move the food, but it's boring because I'm fully in control and I cannot be really killed unless I do it on purpose. So we need to somehow tell the game to move the food on its own. And for this, we're gonna use observable of interval. Interval is like a standard set interval in JavaScript. So you fire a certain event on some specific time slot. We're gonna do this on game speed, which is currently set to 100 milliseconds. And again, let's just subscribe to see what's coming through. So now you can see that the numbers are being printed down. And we don't really care about the numbers, right? We would like to have this move down action. So we're gonna map whatever comes through to the GameAction.move down. Now again, if I press some key, we have the game. But nothing is really happening because we are not mapping now this game down to our state. And since we have two observables that are both changing the state, if I would again repeat the code with a scan, we would have two states competing each other and the game just wouldn't work. So we're gonna combine these two. Now let's call this first one observable the key down observable. And let's call the second one time observable. And now we're gonna get rid of this subscribe because that would be subscription and not the observable. And we can take this bit and we can now merge those two together. So we're gonna merge key down with time, and we're gonna set our pipe, and we're gonna paste this stuff. So now whenever each one of these is firing, they fire the event directly to this scan, which then generates the new state, and then we render the state. Now, as you can see, there's this really, really annoying refresh rate. And that's happening because initially I'm loading every image whenever there is a change. So whenever we need to redraw the state, I again reload all the images and wait for the images to actually be loaded to the DOM and only then render them. And this is not ideal, of course. So I created a small handy method called Preload images, and we're gonna wait for all the images to be preloaded, stored in this image tag that you saw initially, and only then we're gonna start our game. Now you can see that there's no flickering anymore. So the game is working on its own. Now, one thing I promised was to tell you about the calculated state. So let's just check quickly what's going on here. So we have our first check is whether the game is still on. If game is not running, then just return the state. There's no change to be applied. If we don't have any more lives, then please set the game on to false or end the game. And finally, if we have moved down, we need to first apply the new position. So we calculate the new food Y. And then if the food is just slightly above the chef, meaning they would collide or miss each other, based on the position, we either increase the score or we reduce the life. And finally, once the food ended its life through the screen, we're gonna generate a new food item. And also for the chef X and Y position, we simply just calculate the new position. And there's also this method calculate food, which is there just in case the food is too slow and we manage to catch the food, but then press left or right, in a way escape the food. So we would like food to follow because it's already in the basket. Now let's go back to our game. So we have now full logic, and you can see that once the game has ended, we have this game over. Now this is all really nice, but is the game actually over? Let's try to console log something like new date, and then get the time just to see what's going on here. So now you can see the timestamp is being printed out, and we're gonna now just try to intentionally kill ourselves just to see what happens. You can see that the game is over, but the observables are still running. Because we have this interval, as I said, was hot observable, and both key down is hot observable, so both of them are running at the moment. And this is not ideal. We're not doing anything to the state. We're just returning the same state over and over, but our renderer keeps rendering pretty much the same stuff over and over. So we're gonna apply one more operator, which is called take while. And this one says that the observables should run while some condition is met. And we're gonna say once state is game on, run this game, otherwise kill the observables. Now let's hope we're gonna have some super fast food falling down, because this might take ages. Initially I had the idea that I will speed up the game as it goes, but it would just complicate things, and that wasn't the point. So now you can see that the numbers are not rendering anymore. That means we have killed our observables, which is what we wanted. Now, one more thing you might have noticed is that every time the game starts, there's like split second of the intro. And we would like ideally to show this intro a bit longer. So I'm gonna say, again, pipe, and I'm gonna put a delay here. And I'll say, wait for 3000 milliseconds or 3 seconds. Now you can see we have the intro shown first, and then the game starts. And as you can see, this, although it's rather simple game, the logic itself is quite condensed. So we did some coding upfront about rendering and state management, but most of the logic of the game is actually within this 20-ish something lines of code. And I did similar game with Tetris, which is slightly more complicated, and the lines of code for the logic were exactly the same. So you can see how you can easily build something that usually is quite complicated, like logic in the game. Now imagine what you could do with your enterprise applications or your any-day applications by using this observables. Now let me go back to my slides. So if you would like to see the source code of this game, you can head over to this short URL with RxJS Chef. If you would like to see these slides, they are also on bit.ly with Armada slides. My handle again is Miroslav if you would like to tweet me, follow me, or whatever. I'm also using on some social networks missing manual in case you're not using Twitter or GitHub. And this is my website. There are some blog posts there if you want to have a look. All of the photos on the slides are from Unsplash, and all of the, or most of the graphics actually in the game. Some was hand-drawn, but most of the graphics are from Flaticon. So go ahead and use these websites because they are really cool. And with that, I unsubscribe. Thank you.
All right, thank you for the awesome talk. And this time we really have a couple of interesting interesting questions. We have interesting situation here because we received one question before the first talk, and we assumed it's related to this talk. That's why we saved it for later. And here it goes. Why so many similar methods for observable exists? Can it be standardized in few methods?
That was the question I was asking myself as well. As I mentioned, there are 100-something operators, and this actually keeps changing from version to version. So they figure out something is not used as much or doesn't really make sense, so they deprecate it and they build the new operators. Now, although these operators might look similar or same, they're actually doing slightly different things. And usually you have like one generic operator that can be applied to any situation, and you can have some more specific operator, like for example, debounce time and debounce. So debounce accepts any async function that will have some time that passes until it's finalized. And this is really generic, so you can feed it with whatever async function. And debounce time is like a subset of this function, where you have to specifically set a time. So instead of using debounce and writing function calls set interval JavaScript to 1000 milliseconds, so you have to like write this chunk of code. Instead, if you just need to debounce it for 1 second, you just write debounce time 1000. And this is how most of them work. So you have something that is already simplified for you, so you can easily use it. But if you have some specific scenario that doesn't match this, then you can use the broader version. So I hope that answers the question.
Okay, let's move to the next one, which says, what are the bad things about reactive programming / observables compared to promises?
So I wouldn't say there's something wrong with observables. Actually, I haven't found anything wrong. The only negative or potentially negative thing is that, as they say, since ReactiveX is quite complicated and there are many ways how to do certain things, there is also more space than in promises to shoot yourself in the leg if you would like to. So you really have to be careful. And with promises, it sometimes happens that you leave your callback behind and you have some memory leak. In observables, this is super easy. And you really have to be careful to close your observables on time. Now, if you use observables within something like Angular, it is usually handled for you, so all the observables that are linked to your template are automatically thrown away once the component has finished its lifetime. But if you're using it in some random TypeScript or JavaScript projects, you have to be careful with this. As you saw in this game, if I wouldn't call take while, the game would just keep running and running, although there was no point. So this is one of the, let's say, negative things. And the other one was the whole definition that I mentioned in the beginning, that it's not that simple to explain Rx, and you really have to kind of go out of the standard templates for explaining things. And most of the stuff on Rx was explained with marbles, and marbles work perfectly for simple things like map, filter, something else. But if you would like to use observables of higher order, using marbles is quite difficult. It's like trying to use Abacus to explain how integrals work. Just the tool just doesn't match. So that's, I guess, one of the biggest issues of Rx, that people just find it hard to learn or to understand how certain operators work.
Okay, thank you. Next question in line, according to upvotes, is in an existing, in brackets, large React application, how do I start introducing RxJS?
So, as with any other application, not just React application, I would probably, unless you have really space to do a big bang and switch everything to be reactive, I would probably start with some simple component and see where I have some sort of reactiveness involved and try to replace this with Rx or wrap it with Rx. Also, you can start with replacing some promises, especially the ones that you would ideally like to cancel. Like, imagine a user is clicking on some button on the page and fetching some data constantly. What you would like to is, if user then clicks back, you don't want this promise to still stay hanging on waiting for the response from the server. You want to detach from this and go back. So this is ideal place for using observables because they're cancelable.
Okay, thank you. Next question is how RxJS can even more evolve in the future? Your idea/thoughts.
So I guess the good way of RxJS to evolve would be to become part of JavaScript definition. So to become the part of standard. And as we now have promises in JavaScript, hopefully one day we're going to have observables as well. The slight issue now with observables is that each operator you brings a couple of bytes or even kilobytes to your page. So you can go really crazy and bring all the 100 operators to your application, but inevitably your application will just explode in growth. So with adding new operators, you have to be careful and to only bring the stuff you really need, especially if you care about performance and speed of your application. If this would be part of the standard, this would of course come directly from browser and you would be all cool lying because there's no additional data coming through.
Thank you. Next one. What about you? Oh, sorry. Just got one question upvoted. Should we use RxJS in Node.js?
Yes, I think it's also beneficial to use RxJS in promises, though for the Node, you have also some solutions which are a bit more advanced than promises and gives you the cancelable promises. So the benefit of cancellation, so bringing the observables just for the cancellation's sake, doesn't really matter in Node.js, but I think you would still benefit from having RxJS on your server side.
Okay, thank you. Next one, what about using RxJS to store data from database and using like cache?
So, of course, RxJS can be used in any situation, so I don't see any issue in using it directly to fetch data from database to the cache. Of course, you would have to create some subscription and make sure this subscription doesn't end up running in the application and eventually eating all your memory.
Okay, thank you. And that will be all for this Q&A session. And given that we have more than 5 questions still here, I advise you to find Miroslav later and ask those questions that you have sent. And upvote your favorite questions for next talks.
One more thing I wanted to add. I have some stickers from Angular Austria, Angular Vienna, and RxJS. So if you would like to pimp up your laptops, find me after the talk.
There you go. Thank you.
Thank you.